Hello everyone, I'm Kunal, and today I'm going to explain electronegativity trends in the periodic table. So, what is electronegativity? It can be formally defined as a measure of the tendency of an atom to attract a bonding pair of electrons. This basically means that atoms that are very electronegative will attract electrons greatly. It's important to note that electronegativity is only used within the context of covalent bonding. This is because the electronegativity of atoms in a covalent bond will determine how the electrons are shared. And, for example, in an H2O molecule, the oxygen atom has the greatest electronegativity when compared to the two hydrogen atoms. This results in the shared electrons in the OH bond to be closer to the oxygen because it is more attracted and further away from the hydrogen atoms. It can be seen in the dipole moment. Now, moving on to the periodic trend. This is a table with the electronegativity values of elements. The values are relative and only represent to what extent an element is electronegative compared to other elements. So, there is no units for electronegativity. As a general rule, electronegativity increases from left to right in a period or row in the periodic table. This is true because moving down a period results in an increase of protons in the nucleus of atoms, while the number of electron shells remains constant. As protons have a positive charge, this increase causes electrons to be more attracted to the nucleus of the atom because opposites attract. And in turn, this causes an increase in electronegativity. Now, electronegativity decreases as you move down a column or group in the periodic table. This is due to the increase in the number of electron shells in each row. The greater amount of electron shells in an atom causes a concept known as electron shielding. This is where inner shell electrons shield or block outer shell electrons because of the negative to negative charge repulsion that two electrons experience. The more shells also increase the distance between the nucleus and the bonding pair, and in turn decreases the attraction between the two. So, as electronegativity decreases down a column, it's going to increase the opposite direction. And you will see some exceptions to these rules when moving left to right between elements. And for example, group 6b to group 7b, which is here, group 6b to group 7b. We can look at chromium and manganese. Normally, electronegativity should increase left to right. However, in this case, chromium has a greater electronegativity than manganese. So, this is due to the fact that atoms are stable when their orbitals are half-filled or fully filled. In this case, manganese has a half-filled d orbital. Therefore, it does not want to gain an electron and its electronegativity value is low. On the other hand, chromium only needs one more electron to be considered stable and achieve a half-filled d orbital. Therefore, its electronegativity value is higher because it wants an electron. And manganese has a half-filled d orbital because there are 10 electrons total in the d orbital, and manganese has 5. So, another exception to these rules is noble gases. As you can see, they're not included in this table. Normally, there would be a column right here, and they're not included because they don't have electronegativity values. Since noble gases already have a full valence shell of electrons, they are considered extremely stable and don't need for attracting electrons, and therefore do not have electronegativity. I hope this helps, and I'll see you guys in the next video.